Let's be honest. When you think about the AI revolution, there's really only one name that comes to mind: Nvidia. They are the undisputed heavyweight champion, powering just about everything in the AI space. So today, we're going to break down their latest and, frankly, very surprising strategic move. I mean, their GPUs are the absolute gold standard. They're the foundation this entire industry is built on. Nvidia is so far ahead of everyone else, they seem completely untouchable. They're just playing in a league of their own. But here's where it gets weird. This giant, this untouchable king, is quietly snapping up key talent and tech from a tiny, super specialized startup called Groq. That's Groq. Which leads to the big question: why? Why would a company that basically has a monopoly on AI hardware need anything from a small fry? What kind of secret sauce does this little company have that the most powerful chipmaker on the planet wants to get its hands on? Well, that's the mystery we're unpacking. All right, so let's get into it. Who is this company, Groq? It was founded back in 2016 by Jonathan Ross, who just happens to be one of the masterminds behind Google's famous AI chip, the TPU. And his mission with Groq wasn't to take on Nvidia head-to-head. Nope. His goal was to do one very specific thing, and do it better than anyone else on the planet. And this is where it gets really interesting. Groq doesn't make GPUs, right? Graphics processing units. They invented the LPU, the language processing unit. Its only job is something called inference. Think of it this way. Training is like sending an AI to college for 4 years to learn everything. But inference is the pop quiz. It's asking it a question and getting an answer back, like right now. And Groq's LPU is built for nothing but that blinding speed. So how fast are we talking? Well, how about 500 tokens per second? Now, in the world of AI, a token is just a little piece of a word. So 500 tokens a second is roughly 375 words every single second. That's not just fast, it's surreal. You ask a question, and the answer is just there. There's no lag, no waiting, it's basically instant. Okay, so you're probably wondering, how on earth is that even possible? It's not some clever software trick. The secret is buried deep in the chip's architecture. It really all boils down to this battle between two types of memory: SRAM versus HBM. This slide lays it out perfectly. Think of a regular Nvidia GPU like a world-class chef. Their pantry, that's the HBM memory, is super fast and right next to the kitchen. But the chef still has to run back and forth to grab ingredients. It's a tiny delay, but it's a delay, a bottleneck. Now, Groq's LPU, well, they basically put the pantry inside the oven. The processor and the memory, the SRAM, are fused together on the exact same piece of silicone. There's no running back and forth, no bottleneck, just pure, unadulterated speed. Okay, so what's the catch? This chart really breaks it down. HBM is great. It's the flexible, cost-effective choice, especially for training these huge models. But SRAM is all about raw, blistering speed. The downside? Oh, it's a big one. It is wildly expensive and takes up a ton of precious real estate on the chip. And that's why Groq's chips are so niche. They sacrifice everything for that one thing: speed. Which, of course, brings us back to Nvidia. If their own way of doing things is so good, so successful, why are they even looking at Groq's super expensive, specialized tech? Well, it's because Nvidia isn't just thinking about today's products. They're playing chess, and they're thinking about the future of AI supercomputers. You see, as Nvidia starts wiring together thousands and thousands of their GPUs into these monster systems, they run into a total scaling nightmare. Forget one chef. Imagine trying to get 10,000 chefs in 10,000 different kitchens to all perfectly coordinate making one single meal, down to the millisecond. The delays, the communication, making sure everyone is perfectly in sync. It's a massive, almost impossible engineering headache. And that's the wall Nvidia is starting to hit. And that right there is the key to this whole thing. See, Nvidia isn't planning on ripping out its powerful GPUs and replacing them with these specialized LPUs. That would be like getting rid of your entire kitchen and just keeping an oven. It's not about the chip itself. It's about the idea behind the chip. So what's Nvidia really buying here? Two things. First, you've got the brains, the absolute elite engineers who figured out this whole low latency puzzle, not just at Groq, but at Google before that. But second, and this is the really big one, they're absorbing Groq's entire design philosophy. They're learning how to build these massive systems where everything is predictable and perfectly timed. That's the secret sauce they need to solve their giant synchronization problem.
This move points to something way bigger than just one company's strategy. We're talking about the next chapter in how computers work, period.
You see, the first big phase of the AI race was all about one thing: building bigger and bigger models. It was an arms race for training power. And let's be real, Nvidia completely dominated that race. But now, the game is changing. It's not enough anymore to just have the biggest, smartest AI model sitting in a data center somewhere. The real value is shifting from what the model could do to what it can do for you right now in the real world. Which means it's now all about getting the fastest possible answer. That's the new battleground: speed, efficiency, real-time response. The winner is going to be the one who can deliver an answer not just correctly, but instantly. And NVIDIA's move here, it shows they know exactly where this fight is headed. So when you see the rise of these hyper-specialized chips like Groq's LPU, it really makes you wonder, right? I mean, we went from general-purpose CPUs to specialized GPUs, and now to these laser-focused LPUs. What's next? What other kinds of single-purpose, mind-blowingly fast chips are being cooked up in a lab right now that are going to totally change the game all over again?